Welcome back to the deep dive. We are here to deliver the ultimate shortcut to being well-informed. And today, we are tackling a giant that sparks, well, a lot of debate. Cardano, known by its token, ADA.
That's right. For you, the curious learner joining us, our mission today is pretty clear.
Okay.
Cut through all the complexity and really understand Cardano's core value proposition.
Okay.
We're going to look at its unique scientific foundation and try to figure out why this project, founded by an Ethereum co-founder, consciously chose this path. A path defined by rigor, really, rather than just speed.
And it's definitely an essential project to understand. So to give you the quick snapshot, Cardano is a major third-generation proof-of-stake platform founded by Charles Hoskinson, who, was one of the original co-founders of Ethereum.
Right.
But its truly differentiating factor is how it's built. The entire system is designed and implemented using peer-reviewed academic research.
Yeah, and that commitment to academic rigor. It's not just a footnote. It pretty much defines every single choice they've ever made.
Okay, so let's set the stage then. Bitcoin was first gen, Ethereum second gen. What problems, what fundamental issues was Cardano trying to solve when it came along? They weren't just making another coin.
No, definitely not. They were aiming squarely at what's often called the blockchain trilemma. That inherent difficulty of getting security, scalability, and decentralization all at the same time. It's tough.
Right, the classic challenge.
Exactly. Cardano's whole premise was that, first-gen chains like Bitcoin, too slow, too inflexible. And second-gen chains, especially Ethereum back then, didn't quite have the proven security and scalability needed for really big global institutional level stuff.
Ah, okay. So the ambition was fundamentally infrastructural from the start.
Precisely. The main goal, driven by IOHK, the engineering org behind it, is financial inclusion. They talk about providing stable, accessible financial services to the, quote, 3 billion people worldwide who currently don't have access to traditional banking.
Wow.
Yeah, they're building for national adoption, not just for new crypto traders or DeFi users.
Okay, but if the ambition is that big global infrastructure, maybe national financial systems, how do they justify taking all this time, building so deliberately, when the market's just flying past them? That seems like a huge risk, a massive trade-off.
It is the ultimate trade-off, and that really brings us to their core philosophy. Most tech, especially in crypto, runs on that move fast and break things idea. Build something quick, get it out there, grab market share, like building a trendy modular home quickly.
Right. Get it done fast?
Cardano is the exact opposite.
Okay, tell us the skyscraper analogy. I like that one.
Right. So Cardano is building a skyscraper designed to last like a century. And they absolutely refuse to pour the concrete for the foundation or build the next floor until the blueprints, the code, the structure underneath have been completely exhaustively peer-reviewed, tested, and scientifically proven to be sound.
Okay, that makes sense. Methodical.
Extremely methodical. And that rigor, that's why development feels so slow sometimes. But the promise, the payoff, is supposed to be unparalleled security and long-term reliability. The very conscious choice against that Silicon Valley hype culture.
Which means their goal isn't just payments. It's aiming to be, a secure, transparent, fair, global operating system for finance and society?
That's the vision. A global, social, and financial OS.
Okay, so let's dig into the architecture then. How does this super secure, carefully built design actually work? How is it implemented?
Well, a key part is that they physically split the network into two distinct layers. Think of it like that skyscraper having two separate stories built for different jobs, for efficiency and safety.
Okay, two stories. One handles the money, the other handles the complicated stuff.
Exactly right. So the first floor, the ground floor, that's the Cardano settlement layer, CSL. This is the rock-solid foundation, optimized only for transferring the ADA token. Value exchange. Maximum security, maximum speed, just for that core function.
Got it. Simple and secure for the value. And the second floor, the computation layer. CCL.
Yep, that's where all the complex software lives, your smart contracts, your decentralized applications, DApps. By keeping these completely separate,
I see.
any heavy traffic or a bug or, just general congestion up on that software floor, the CCL, it can't possibly slow down or mess with the basic money transfers happening on the ground floor, the CSL. That separation is key to its resilience.
Okay, that makes a lot of sense. And powering all this is their consensus mechanism. It's proof of stake, we know that, but they use something unique called Ouroboros.
Ouroboros, yeah, that's crucial. The sources we look at really emphasize it was the first proof-of-stake algorithm that had mathematically provable security. That's a big
Yes,
claim.
provable security, okay.
And it's also vital from like an environmental standpoint. It's apparently millions of times more energy efficient than the old proof-of-work systems like Bitcoin.
Right, huge difference. So for an individual user, how does this Ouroboros thing work? How do you actually participate in securing the network? You called it a fair lottery before.
Yeah, it's kind of like that. The network runs in these 5-day cycles called epochs.
Mm-hmm.
As a user, you take your ADA and you delegate it. You assign it to one of about 3,000 independent stake pools operating around the world.
All right.
Then the network randomly picks pools during that epoch to create the next block of transactions and earn rewards. Your pool's chance of being picked, it's directly proportional to the total amount of ADA delegated to it. So more stake, more chances.
So you earn rewards and you're helping keep the network secure just by holding and delegating.
Exactly. You're contributing to security just by participating.
That's pretty compelling. Okay, let's talk transactions. We've all felt that pain on older blockchains. You send something complicated, it fails for some reason, maybe the gas price spiked, and boom, you've lost your transaction fee anyway. Cardano uses this EUTXO model to fix that, right?
It does, yeah. EUTXO, Extended Unspent Transaction Output. It's basically, think of it like a fixed price menu at a restaurant.
Ah, okay. Meaning I know exactly what I'm paying and exactly what I'm getting before I order.
Precisely. Unlike some other blockchain models, where the final cost, or even whether the transaction succeeds, can be a bit unpredictable until it's actually processed.
Yeah, the surprise bill.
Right. EUTXO gives you the exact cost and, critically, the exact result before you even send the transaction out to the network. This predictability, this determinism, it eliminates all that frustration and, importantly, the wasted money from failed transactions.
And that predictability isn't just a feature, it's baked into the code itself.
Yes. They get this reliability partly because their core smart contract code uses Haskell. It's a functional programming language known for being extremely reliable and, well, predictable in its execution. That choice underpins the stability.
Okay, so we've got this super reliable, maybe slow building, but highly secure architecture. Where is that actually translating into real-world use? What are the big wins we can point to?
Well, the biggest bragging right is probably the 100% network uptime record.
Yeah.
Never gone down. That's hugely attractive for governments, institutions, anyone needing rock-solid reliability for critical stuff.
Can't argue with 100% uptime.
Right. And the flagship example, the one they always point to, is that massive project in Africa, a partnership with the government of Ethiopia.
Ah, yes, the education project.
Exactly. Providing digital identity and tracking academic credentials for over 5 million students on the blockchain.
5 million. That's a staggering scale. That really shows what that national adoption goal actually looks like in practice.
It really provides the proof point for the utility, yeah. Beyond that big government deal, they've also got some corporate adoption, working with companies like Dish Network and New Balance, the shoe company,
Right.
for things like product authentication, supply chain tracking, that sort of thing.
Okay. And for the individual ADA holder, we mentioned earning passive income through staking, but there's also the governance aspect, right?
Correct. Holding 80 basically gives you two main functions. One is staking for rewards, and the numbers are significant. Over 1.34 million wallets are actively delegated right now, securing the network.
Wow. Okay.
And the second is governance rights. Cardano is currently in what they call the Voltaire era of their roadmap. This means ADA holders actually get to vote on project improvements, new features, and crucially, how the project's treasury funds, which are substantial, get spent. He gives the community real ownership over where the project goes next.
You know, this is a great point to quickly pause and remind our listeners of something.
That's right. If you're enjoying how we break down these complex projects into simple pieces and want more analysis just like this, make sure you subscribe. We do all the complex research, so you don't have to. Okay, so we've laid out the strengths, the careful design, the real-world projects. Now let's inject some necessary friction here. Despite these big wins, that slow, methodical pace definitely generates some pretty harsh criticism. What are the major risks, the speed bumps Cardano is hitting right now? Yeah, the number one criticism, and it's totally tied to that academic philosophy, is just being too slow. that rigorous peer-review everything approach. It led to significant delays in launching key features, especially smart contracts, put them years behind some of the more agile competitors.
And that delay directly impacts the metrics that, let's be honest, the wider crypto world really cares about, especially total value locked, TVL.
That is the absolute core of the most damaging critique, the whole ghost chain narrative you sometimes hear. While Cardano often has a really high market capitalization suggesting people see huge future promise its actual TVL, the amount of money locked up and being used in its BeFi apps, it's only in the $350 to $466 million range, roughly.
Okay, and just for context,
Right.
compare that to rivals. The sources mentioned Solana.
Exactly. Solana's sitting comfortably over, $11 billion in TVL.
Yeah.
And a massive, massive gap between the market value and the actual DeFi activity. Well, it fuels those critics who say Cardano is mostly potential, not yet proven delivery, at least in that specific DeFi space.
Right, potential versus practice right now.
Absolutely.
Yeah.
Then the second major internal challenge, it comes directly from their choice of coding language. Haskell and Plutus, the smart contract platform. Great for security and predictability, like we said.
Yeah.
But it creates a really high barrier to entry for developers.
Why is the barrier so high? Isn't secure code worth learning?
It is, but secure code needs developers who know how to write it securely. The pool of developers who are really fluent in Haskell is just tiny compared to the huge communities around languages like Solidity, which Ethereum uses, or Rust, which Solana uses.
Ah, okay. So fewer builders available.
Exactly. If you're trying to build out a big, vibrant ecosystem of applications quickly, that scarcity of developer talent really limits how fast and how broadly you can grow. It's a bottleneck.
Okay, and finally, we have to talk about the elephant in the room, the regulatory cloud, especially in the US.
Yeah, this one is. It's arguably the most significant external threat right now. The U.S. Securities and Exchange Commission, the SEC, they have explicitly named AD, Cardano's token, as a potential unregistered security in lawsuits they've filed against major crypto exchanges.
Ooh, that's serious.
It's incredibly serious. If the SEC's view prevails in court, if ADA is formally deemed a security in the U.S., that presents a massive, almost existential risk. It could mean ADA gets delisted from major U.S. exchanges, cutting off access for American investors, especially institutions, and really hitting its market liquidity and viability hard.
Wow, that is a huge hurdle, puts that global ambition right up against U.S. regulatory reality. Okay, so let's try and wrap this up. Given the huge successes like Ethiopia, but also these major criticisms around TVL, speed, and the regulatory threat, what's the final distillation, the one-sentence summary of Cardano for someone trying to understand it?
Okay, boiling it down. Cardano is fundamentally a long-term play. It's a highly reliable, scientifically engineered blockchain platform that consciously chooses provable security, long-term sustainability, and big state-level adoption over speed. But right now, it's definitely battling market perception, that ghost chain critique, and some very serious regulatory headwinds because of that slow, methodical approach. So the story of Cardano really is about a profound choice of values, isn't it? Yeah. Prioritizing correctness, safety, maybe longevity over just being first or fastest.
Exactly.
And that choice, that whole philosophy, leads us to a really interesting final thought for you, the listener, to chew on. Cardano's endgame, this Voltaire era we mentioned, is all about becoming fully decentralized, handing over control of the keys to the kingdom, so to speak, entirely to the community. So the question is, if they actually succeed in doing that, if Cardano achieves what regulators might call sufficient decentralization, could that be its ultimate defense against being classified as a security? Could proving that long-term, community-led governance is actually the ultimate security measure, protecting it from both technical hacks and regulatory capture? Something to think about.